this session. It should be about 20 minutes. We're trying to keep it a little shorter, respect everybody's time. This session is going to be recorded. Everybody who registered will get a notification about the recording. We will also be putting it up on our YouTube page, which if you don't subscribe to our YouTube page, you really should. We have thousands of subscribers. We have great content up there, not just EV related, but everything related to the auto industry and heavy vehicle industry. By my clock, it's 1 p.m. So I'm going to kick it over to our two speakers. With us, we have Nathan Banky, our Director of Education, and we have our EV expert, Dave Giles. You guys go ahead and take it away.
Thanks, Jim.
Thank you. Thank you. Thanks, everyone, for joining us today. We're going to be doing a session on getting started with EV curriculum. I actually just turned off. I'm hoping everybody can still see me as well as see the screen. My screen was doing some flickering there when Jimmy was talking. So if it's all good, maybe Nathan, are you seeing me okay?
Yes, we're all good, Dave.
Okay, great. Perfect. Okay, so we're going to get started. Like Jimmy says, this is a short session. This is like a trainer's break session where we're going to go through some of the things about getting started with EV curriculum. This has been comprised basically from many instructors, teachers that have contacted us and asked us about where do we start, where do we get information from, how do we start building that curriculum. And so today we're going to hopefully give a little insight into that development. You want to say anything, Nathan, there? Or?
No, we're all good.
Good, perfect. Okay, so I'm going to try and move this, advance this here. See if it'll go. Oops. Okay, so just a little intro slide. We're moving on. So many challenges come up with electric vehicle curriculum. One is time restrictions. I hear that all the time. I meet with school administrators. I meet with deans. I talk with several instructors from those exact schools. And one thing is that everyone wants it yesterday. So and of course, the development of electric vehicle curriculum is time consuming, sourcing parts, components, getting familiar with it. And that's where it comes to the experience level. Like, if you've never worked on an EV before or even driven one, and then you're expected to teach about them, that's a bit of a learning curve for some people. So once again, trying to get that, that start of the project. Where do I start? I've never driven one. I may not even like EVs. Like, I'm not interested in them, but it's part of our curriculum. And of course, the school or dean or program requires you to start teaching that. So it's how do we get the training aids? And this is a big thing. I get asked all the time. I strip cars, electric vehicles. I've done well over 50 plus, all different makes, models. Components from there will go to training aids in the past or used in other vehicles, but it comes down to the parts are very hard to get. It's because the cars are new, and and a lot of them wind up getting fixed when they're in accidents, and sometimes those used vehicles that are available are sold very quickly because the market is very short on EVs in many areas. So it's very hard. I just actually had someone that just lost their Ioniq 5 to total loss in a collision, and they're telling her it's going to be over a year to get a replacement vehicle. So once again, sometimes it's hard to get these types of vehicles and that for your training curriculum. And that's why training aids become very valuable. When you can access them in the proper and the right training aids is also important as well.
I'd maybe add a little point here, Dave, about the time restriction. I see it in a lot of schools that we talk to, ending up with conflicting messaging from different organizations. Okay, whether it is your state level organization or your advisory committee or the administration of your school might be trying to pull you in one direction. And then you might have your program is in the other direction. I've seen many schools and spoken to some recently where the teachers are gung-ho, they're excited to get EV in their program, and either their program is outdated because of their jurisdiction, their state or their province has got their program is 10 years old or 15 years old and it's due for renewal, and they don't have yet the time allocated in the program. So the time restrictions, the budget, And, you know, the level of expectation is something that I think a lot of schools are still struggling with. Suggestion for a lot of the schools is to bring that up with your advisory committees. If there is a conflict, because again, we've seen that often, if there's a conflict in one side saying we need more EVs, the other side saying, no, we don't need to teach any of that right now, or it's not in the program, bring that up with your industry folks that are supporting you. And hopefully that can get you some clarity and eventually get you a direction with the time, the budget, to set it up in your school.
Yeah, it's perfect. That's exactly it. It's you know, and the cost and that budget is a big factor as well too, because a lot of schools, you know, go, we don't have anything EV. We have nothing. Where do we start? Like, you know, we don't even have a car. We don't have a charging station. We have nothing. In fact, that's what we're going to be looking at today, is what you may already have that can help you teach electric vehicles, even with some of the products that you may already own or already have, and how that curriculum can look when you first get started. So that's what we're going to start off with today. We're going to be looking at the ABCs of electric vehicle curriculum. So talking about electric vehicles and a curriculum, a lot of people like to jump right into the service and maintenance side, the battery technology, the motor drive units, the different types of components, and almost making it more complicated than they need to when they first get started. And I always tell instructors, the first thing part of the curriculum that you should be looking at is looking at what is it? What are you trying to do? What are you trying to put across? And the introduction to electric vehicles is a great way of putting that. And I put a little bit of a slide here. And as you go through this is a very high level, you don't need a lot of products to do this. You don't need a lot of components, but it gives a list that can really you know, put that motion in place for electric vehicle training. The history of electric vehicles. Everyone thinks electric vehicles are new technology. They were around in the 1800s, and there was thousands of them on the roads back then. We have battery technology. You know, what's happening in our side of the world with battery technology. You know, we have solid state batteries around the corner. We're using sodium lithium batteries, and you know, and what is lithium ion batteries compared to nickel metal hydride battery? And you know, so these are some of the things that can be brought up. We look at all the different types of drive lines, charging infrastructure, efficiency, talking about why are electric vehicles so different in the sense of, you know, their capacity of energy storage compared to a combustion vehicle. So looking at that energy and efficiency, there's some great calculators. I use them all the time when I'm doing electric vehicle training as an introduction to show, you know, what a student or what a participant in a class, you know, I ask them what kind of vehicle you drive. They say, oh, I drive a Honda Accord. I go, what's your average fuel consumption? And then I use that against a cost calculator, and they realize how much they put in fuel into this vehicle over time. And, you know, and then you can compare it to an electric vehicle. So once again, setting that stage. The environmental impacts, you know, you're not burning combustion fuels, you know, you don't have the regular oil changes, or if any oil changes on them. You know, so these are some of the benefits of that. And charging at home, part of that efficiency and reduction, range and performance. This is where my world is like the performance side of it, instant torque. You know, young people that are interested in coming into the trade, you know, obviously they like cars and the technologies behind these cars, and whether they're old or new, they're fascinating because the engineering behind them. So, you know, and we look at the economics of electric vehicles, that cost savings. Jimmy and I were just talking about that. Like, you know, so, you know, imagine I have a 500 horsepower electric vehicle that I get equivalent to about 32 cents a liter per 100 kilometers on it compared to a gas vehicle. So like, you know, so my fuel efficiency is really great with tons of performance. And doing that into gallons, I'm not really sure what that calculation is. So, but anyways, but it's, you know, it's a fraction of the cost. And, you know, and range on these vehicles getting more. We have the government involvement talking about how the government's involved with electrification of transportation, so talking about, that and, the rebates and policies around this as we're getting more into the later years towards our goals of in some places is 2030. Others is 2035. There's going to be shifts in dates. I don't dispute that for when we end combustion vehicle sales, new ones. But the thing is, they're still going to be here and they're still going to be on our roads. So then we're going to look at market trends. We see new manufacturers coming up all the time. So, and it's exciting because it's continuously building on itself. And I said in our last seminar that today's gasoline vehicles are getting better because of electric vehicles. Electric vehicles are proving that they can outperform a gasoline vehicle. And that's taking gasoline engineers or engineers and manufacturers to make them more fuel efficient, more powerful, longer lasting. So these are all benefits that we see in the industry, part of these changes and trends with electric vehicles. And this is just a very standard way of introducing electric vehicles to to get students engaged with why we're doing this, how we're going to be doing it, and what we're going to be doing with electric vehicles as we move on.
Maybe just one other thing to add there, when we talk about also the government involvement, rebates and policies, this is the main source for a lot of the schools in being able to get the funding to develop a new program. And there's some schools that I recently visited that, what they're doing now is instead of adding it to an existing program, they're adding it as another 6-month course. They've gone and gotten funding from their funding body, from the government or state level organization to develop a new program and add it on. So you might have a 2-year diploma program, and now you're going to have a 6-month on top of that for technicians or for your students coming out of that diploma program to become an EV certified technician. So there's a lot of government funding at many levels to help with that.
Yeah, and it's exactly it, because once again, government's involved very much at many different levels, even from training to, accessing products and so on, rebates to the consumer. There's lots of things, even charging stations and charging infrastructure that's going in is getting, once again, getting more and more government funding, and we're going to see more charging and so on. So, but let's move on to number B, or letter B, I should say, the A, B's, C's of electric vehicles. And this comes down to, okay, now I got the basics. We delivered, I delivered a program to my students about electric vehicles, the history, and all these great things. Now, what do I need to teach them in order to make them comfortable with servicing and repairing electric vehicles? And it comes down to a few things. Electrical system knowledge is critical, and whether it's high voltage, low voltage systems in a conventional gas powered vehicle or in a high voltage electric vehicle, you have to have the fundamentals of electrical systems. So, different types of circuits, whether it's a series circuit, parallel circuit, within a vehicle itself. High voltage is nothing to play with. How to measure it properly, how to do those tests, and it can be taken right from a low voltage test point and applied to a high voltage test point with the safety aspect in mind. So, and that's where we get into safety specific to EVs. Once again, the types of safety equipment. When do you use that safety equipment? That's a big question. I have schools that buy all the safety gear, and they go, when do we use this? When do we tell the students that they need to use arc flash protection? Or when they, how and when do they need to use a safety hook? Or more importantly, the gloves, the insulated gloves, how to properly maintain them, test them, and when to use them and when not to use them, because sometimes those gloves can be a hindrance in doing a repair, and when there might not be needed. And doing that, you might wind up damaging the gloves too. So different things about these areas. How do you set up a perimeter around a vehicle? What type of work are you doing on the vehicle? So this is all comes right back to the safety specifics of EVs. And that's going to put a little point in there. Our next clinic we're going to be doing is going to be on EV safety. So I'm just going to go through this quickly, but I want to talk about the tools and equipment, getting the students to apply and understand the meters, scan tools, and so on. Once again, talking about battery technology. I got a little thing you can do with your students with batteries, but once again, motor drive units, how they work, electromagnetism, so on, components or function, charging, power system, transfer systems. This is your charging networks, vehicle requirements for service and maintenance, because a lot of times they don't even look it up thinking it's an EV. We were told it doesn't need maintenance, and of course they need maintenance. Diagnosing and repairing these systems, as well as automotive systems that are standard, your regular mechanical systems that are no different than an EV, your tires, your steering, your suspension, and other systems that are related to the vehicle are exactly the same.
Yep.
Okay, so I move on here. C is our final area where how you're going to do this and what you need. And operation of electric vehicle is very important, is seeing how the vehicle operates, how power flows through the components, what the components do, how they supplement or how do they relate to the high voltage system, learning about the terms and acronyms of electric vehicles. I just mentioned about when to use the safety equipment and how to use it. Being proficient with the tools and equipment. You got to know how to use a proper meter when you're testing high voltage systems. Make sure you have the right class of meter. Make sure you're using the meter in the correct functions of that meter, and double checking before you actually take those test measurements. Sourcing information. Once again, where do you get proper information? If you don't have that information, it makes it hard to do that testing. So once again, what information is important, part of your projects, and so on. And also keeping everyone safe working with EVs. And this is the big point in the training aids. And any of the training aids that I've been involved with, ConsiLab, that is the number one thing that comes through everyone's mind with engineering, education, sales is safety. So how can these products be displayed safely to a student, but also demonstrate the actual conditions that these systems will operate in? So once again, high voltage is becoming another side of it. We've had gasoline trainers, we have diesel trainers, and now we have electric high voltage trainers. So once again, keeping everyone safe when they're teaching about high voltage, or students are going to the vehicle to do different tests and so on. So that's why our training aids are very much all safety oriented. We have a really cool one coming up we'll show you in a second. And of course, once again, EV charging equipment. What does it mean? EVSE, electric vehicle service equipment that's out there for charging these vehicles is important to understand. The power conversion systems built into vehicles. So once again, these are all getting started. These are ideas to get you started with electric vehicles. Okay. Curriculum that we developed with ConsiLab is directly related to actual real world scenarios that we have been experienced with electric vehicles, but also what industry standards are as well too. So working with groups and manufacturers. I'm involved directly with a couple OEMs as well. So curriculum is developed in the sense of how it's taught in the classroom. So, we're talking about how is a learner going to adopt some of these advanced technologies and, these different types of electrical circuits and so on, and safety. So once again, our curriculum is very focused on that we provide is on testing and so on. And one of the products I have, or that we're working on with ConsiLab, has well over 75 different industry leading tests to do on an electric vehicle, so which is really exciting. But even some of the trainers that you may already have may be able to help show different systems. For example, a simple Ohm's Law trainer in 1919 here, once again, we're talking about kilowatt hours, voltage, high voltage, low voltage, series, parallel, high voltage interlock circuits. You know, and a trainer like this is really cool because when you're talking to a student about series and series parallel drivetrain, you know, and they're looking on the board and they're seeing how the power flows, and get them actually to build that series parallel circuit on your Ohm's law trainer. You know, very simple way of doing it, but it shows, you know, how, you know, you can have a series circuit powering the electric motor, and then you can actually have a secondary, which is acting in parallel, but it increases the voltage. And we're going to show that we're actually going to do a little video on that to show you how to do that with your Ohm's law trainer. So students actually, after you teach about different types of modes of in the PHEVs or in hybrids, or even in BEV, a battery electric vehicle, a simple Ohm's law trainer, putting a series circuit together, you know, using the little motor instead of a light. You know, and then you add a parallel circuit that has more power to it. And when they engage it, it boosts that motor, you know, once again, to show the operation of a series parallel circuit. So really cool stuff that you can do directly with some of your equipment you already have. Building a high voltage interlock loop, you know, showing how that works and what happens when it opens using your Ohm's law trainer. So these are some of the things that your equipment that you have that you're teaching already during your electronics program. You could drag that back out and use it in your alternative fuels program or your electric vehicle program, and have the students actually doing these circuits. This way, they understand how the series parallel circuit works, but they're also demonstrating it and building it themselves within these trainers themselves. So, which is really, really neat to do because it gives them the hands-on to actually do that kind of stuff. Yeah, and you want to add anything, Nathan?
No, we're all good.
Okay, great. So, okay, just going to be a little aware of our time here, but I'm just going to move on. Training fundamentals. Once again, we have a electromagnetism trainer. That's really great for a lot of this type of training, even though it's used for like relays and solenoids and starting circuits and so on. But on the electric vehicle side, you can do regeneration with it, how the students actually show what regeneration is and how it works, showing induction motors, permanent magnet motors, you know, on the brushless side. You know, so it shows how it relates to the drive units in today's electric vehicles. So now, not all electric vehicles use permanent magnet motors, but, you know, once again, it gives the principles of operation, you know, an inward style permanent magnet motor, or external, you know, either or. It's a great way of showing a student actually sees how it actually works and then can apply it to, you know, their learning on an electric vehicle. Okay. One of the other things is sometimes having the vehicles themselves, and this is a big area that we get asked a lot, is about the vehicles themselves. And we actually do have a vehicle that is designed to work with students. It's a vehicle that allows students to explore the electric vehicle, learn about different aspects about the electric vehicle in all areas, but it being safe. It has no high voltage in it. It's been simulated. You know, a lot of the components, you can drive the vehicle. You can actually drive this vehicle in the classroom. No, it doesn't drive. It doesn't have a high voltage battery, but you can simulate the drive modes with the vehicle through its touch screen. So you can demonstrate what happens when the vehicle is at a certain speed, the battery is really hot, and then you hit the brakes. What happens with regen? You know, so these are some of the things that you can actually demonstrate with the 601. I call it 601. It's actually the IDEV, Interactive Demo Electric Vehicle, but it allows us to, you know, to simulate these things right in the classroom. The student can explore it without any risk of being hurt. And the testing, you can do isolation testing on it, and seeing how the power flows through, especially through the PCS and the contactors and the drive motor and inverters and so on. Okay, so I'm just moving along here. Other products that are out there, you know, that you may already have, but you probably use them in your hybrid training, but a lot of time, or in your electric vehicle training. But, you know, some people say, well, I have a hybrid planetary gear set trainer, but you know what? It's the same setup as what you'd use in a PHEV, a power, plug-in hybrid electric vehicle. So, once again, the theories are the same, the components are the same, the controls on the actual newer vehicles are a little different, but the fundamentals are the exact same. So it doesn't take away from if you have one of these hybrid trainers and you're saying, well, everything's gone electric, it's plug-in now, they're still the same thing. You're looking at the Toyota Prius hybrid drivetrain cutaway. It's, nickel metal hydrate battery's been replaced with the lithium ion battery, and we have a charge controller with a J1772. There you go. You have yourself a PHEV. So once again, these are some of the things that these still have, that have huge value in the classroom to show their operation, how these components work, and showing some of these fundamentals. Okay, I threw this in here. I'm not going to spend a lot of time on it. It's the ADAS trainer. Maybe Nathan, do you want to talk a little bit about this one?
Yeah, sure. And again, this is fitting with almost all the EVs that we see out on the market, are all being new platforms. New modern vehicles come with very comprehensive ADAS systems. This is, again, an example of blending of the technology that you're teaching. The stuff that you're teaching, either on combustion vehicles or on electric vehicles, a lot of it is transferring over between the two. So you can find a lot of ways to integrate EV into your program by finding the common technologies that are across all the vehicles. ADAS one is an excellent example. Again, this is one that ConstLab we developed for use within a classroom that does a exaggerated version of all the functions that you can do with an ADAS vehicle. So you can actually see what's happening up front in the object detection with the camera. You can see the blind spots. You can adjust everything. You can exaggerate the adjustments of everything, and then bring it back into line as if you were doing a calibration, but very, very exaggerated. So we've got some cool stuff coming with that, with some animations that we're going to post up on our YouTube channel. But I think we want to get along to the Q&A period.
Yeah, sounds
sure,
great.
You guys and gals probably have lots of questions for us.
So if anybody has any questions, you can go ahead and put them in the Q&A box, and we will read them off and get any questions answered by our experts, because we want to be considered one of your go-to people when it comes to EVs. We want to be partners with you as you enter this strange new world. Wow, it's pretty quiet in here.
So one of the things I just got, actually, believe it or not, somebody sent me a question on my phone. So I got a question on my phone. Anyway, somebody I know, but one thing, I just want to go back a couple slides here. If you're trying to do some things, is having projects for the students is really crazy. It's really fun for them, and they get to build these things. And I promise I'll have a link for this as well, too, with the video. But they get to build their own 3-phase electric motor. And it's very simple to do, very cheap. They build it themselves. They wind it, and then use a simple Amazon speed controller to do that. So it's a great project because it shows, the integral part of an electric motor, the strength of the magnetic field, the control side as an inverter would control that electric motor. And it's fun when I've done this with other groups, it's like, they almost challenge themselves who can build the smoother motor, the quieter motor, the more powerful motor. And they actually take these and they take them home with them, and they're very cheap to make. And you just keep the speed controller in the classroom. So you can have 1 or 2. I had about 4 when I did. It runs off of a 12-volt battery, just like a RC battery. As well as using insulation testers and water. Like if you're trying to demonstrate how an insulation tester works, take a wire, put a cut in it, and loop the wire into the water, and then take an ohm meter and put an ohm meter on it. Ohm meter doesn't show anything, but when you use the insulation tester with your gloves and demonstrate to the students, and dropping one probe into the bucket of water and the other end into the cable, and then basically pressurizing that wire with high voltage without 500,000 volts, you see readings. And it's a great way of showing how some of these tools work. So there's lots of different little projects that you can do with students, and demonstrating how how these things are constructed and how they actually work. So hopefully,
so we do
that answered your question.
We have a question not really directed at you guys, so I'll take this one. But they asked, if there'll be a copy of this video to share with instructors that couldn't participate at this time. The answer to that is absolutely yes. If you're already registered, you'll get a notification that the recording is available. We're also going to make it super easy on you. We'll edit it down because I think a little bit of our mumbo jumbo at the beginning, we'll cut all that stuff out, and it'll be up on our YouTube channel. We have a EV webinar channel on our YouTube page, so it's something I recommend you go ahead and subscribe to. Here's a question: what type of students would you start with? Would you only teach EVs to apprentices? Does the CSA have to get involved with pre-certification? This person's clearly in Canada.
This is a teacher we know from Ontario, and it's a great question. I think a two-part question there. To me, at least, and I'll let you answer the other part of the question, Dave, but to me, it's all dependent on where you're at. If in your local, as a school, you're serving your local industry, the shops, the dealerships, everyone around you. If the vehicle fleet around you is full of EVs, it's got to be every student. You'd be doing a disservice to your students, to the industry around you, if you weren't at least introducing to all of your students, whether they're apprentices, diploma program students, whatever, regardless of where your program's at, it'd be a disservice to the industry if you weren't at least introducing the students to this technology. It comes back again to what I said earlier around really reaching out to an advisory program, knowing and having a feel for what's going on with the vehicle fleet in the shops around you. If they've only got a few hybrids and a couple plugins, then you might be just introducing that to your higher level students, those that have already completed all the other tasks. And then Dave, did you want to talk maybe then about CSA? This is a certification body specific to Canada. So this would be like a certification like a UL or type of thing, kind of similar in the United States.
Yeah, CSA definitely involved. The new standards for the 22.124 is going to be released in March. A lot more EV storage, EV charging as well within that electrical code, but also on the automotive service technician, they just completed the AST high voltage certification program. I know truck and transport is on its way. I was one of the authors of this new certification program that's going to be offered by CSA. So it's available in the US as well as in Canada. And it's a great way. And just to add one other thing about talking about when do you start teaching EVs, the 601 that's actually in the picture there, I was asked that exact question from a school that has one of these 601s. And right from the beginning, the beauty of some of this stuff, it's progressive. Like you can start off with what is an electric vehicle? What are the components? Where's the battery? Where's the motor? How does it look? What do they look like? Then you go into the next level where you go into technician training, where you do the testing, you start to identify the components and what they are, how they work and what they do, and so on. And then you even go further with it, and you can use as an introduction vehicle as well, especially for first responders. If you're doing some after school clinics, or they're trying to get more involved with the community around them, like as first responders, what happens when you pull the disconnect on one of these vehicles? Where's the battery? How do you handle one of these vehicles in a situation? So sometimes having a vehicle that has multiple uses is very beneficial to any program, whether it's high school right to even colleges and universities. Some even university students engage our vehicles, and they want to know, especially in the mechanical engineering, and they want to see how they're built, where the parts are laid out, what they do, how they work, so on. So it's not just used for just one thing, used for lots of different things.
I guess if I could summarize, I think that if in your area, near your school, the shops and the dealerships around you, if they've got a whole lineup of Ford Mach-E's, a bunch of Ioniqs and some Volkswagen ID4s and a whole bunch of Teslas, and you're seeing those drive down the road and your technicians, your students are working on them, and to me, at the very least, we should be preparing these future technicians to at the very least be comfortable powering down a high voltage vehicle, whether it's a hybrid, whether it's battery electric, whether it's hydrogen powered, whatever it may be, at least being comfortable getting up to that point of powering it down. I want to lead this to another question that we got, Jimmy, from another instructor for heavy duty. I don't know if the specifics, if they're talking about off-road heavy duty vehicles or on highway or delivery trucks and stuff like that. But recently I was talking to a gentleman from Caterpillar, and we were talking about the PPE, the testing procedures. And when we talk about this, Dave and I and others, you know, a lot of it we're relating to how it works on a Tesla, on a Volkswagen, on a Hyundai, on a GM, on a Ford. And most technicians right now are going to get to the point they got to do a bit of work, scan tool work. Maybe they got to power it down to do some major jobs, some major service. And that's about where it ends. And usually when you're doing that type of stuff, you're not getting that far deep into the PPE, into the crazy arc shield and everything. And when I talked to the gentleman, Caterpillar, he goes, no, you got to see on our equipment, you know, the motor drive is rebuildable, and you got to be in there with an arc flash and full suited up, because you're going to be testing 700 volts live to see, because you're going to service one single part of this component. So to answer the question, what are we using for heavy duty EVs, and what curriculum and what similar curriculum? There's a lot of overlap, but where the technician stops is very different. So
here's another question. This is an interesting angle. This person says, I'm an instructor on the collision or in the collision industry. What angle should we go with our training besides powering up and powering down? We haven't really addressed that, so that's a great question.
Yeah, I just came back from the EV repair tour across Canada that was dealing with collision side and auto body services as well. And the big thing that you're going to see in the collision industry is more scan tool use for sure. Components that are no longer repairable, you know, they're replaceable. It's great to have, you know, that aspect to show, you know, the, you know, instead of, you know, repairing a panel, you may have to replace that panel. And some of these components, especially within the structural side, like a lot of these superstructures in the vehicle are under the car now. The battery becomes part of that structural piece of that vehicle. So it's critical in that area. And then, of course, all the other aspects that an auto service technician would see would relate back even to the auto collision technician, you know, from powering down, as Nathan was saying, using, you know, this PPE in certain situations, even from the air conditioning system, you know, even servicing air conditioning system.
Yeah.
Oh, sorry.
That was part I was going to add.
I'll let you do that then.
Yeah, specific for the collision industry is at least having a general knowledge of the thermodynamic systems, how heat and cool is moved around and stored in the vehicle, because you know, when you're working in a body shop and dealing with vehicles that have been in a collision, a lot of the systems that get affected are cooling, refrigerant, AC systems, and now that's going to be the cooling for the power electronics, the cooling for the battery, the heat pump. And having at least a high level overview knowledge of how those systems work, where they work on the car, what their purpose is, I think would aid a technician in the collision industry. That, along with, of course, all that carryover of the ADAS stuff, which is, of course, a hot topic in collision right now.
Yeah.
So we have another question. Will there be a training created for HV battery repair? Some manufacturers are doing this in-house at dealers or off-site.
Yeah, that's a really good question. And HV battery repair is a very specific, it's very specialized. The reason is not so much the complexity of how to repair them. They're not hard. The way they're constructed is not very hard, but how they're constructed in that same sense is like, you know, sealants, testing, bus bars, specialized tools, as well as battery modules. Accessing battery modules is very difficult because even the manufacturers are shortfalled on those batteries, and they're very protected because all the manufacturers that build cars, like the ones we're dealing with right now, like Lucid, Sear, Hyundai, their battery technology is heavily protected. You know, what happens inside that module, they don't want people messing around with them. And plus, that's the highest risk as well. If something happens based on a procedure that wasn't followed completely accurately, it could lead to, you know, disastrous results of a battery failure, voiding warranties and so on. So that's why a lot of manufacturers will bring them right back to their specialized centers for batteries, where their batteries are built, and that's where the repairs and the rebuilds will take place, because they're equipped to do everything at the OEM level. So we're going to see more battery. I know there's shops out there now doing battery rebuilds on the older Nissan Leafs, Toyota Priuses with the nickel metal hydride batteries. But as we see mass market, I've taken apart many batteries, and some of these batteries are not repairable. They are just, I'm going to tell you right off the bat, like you go into like a Tesla 3 or Y, those batteries it'll be a miracle, if you can get one of them to be rebuilt, just because the way the BMS works with them, they're integrated into the battery modules. The modules are about 250 pounds each. There's 4 of them within the pack, and the way they put them in the packs, is very sketchy. I like using that word sketchy. You need specialized procedures and equipment to remove them. I use engineers when we remove our batteries to get them out of these packs, because they are 100 volts each, and a lot of amp hours in them too. So
it's scary stuff, and it's very dependent on the platform and the manufacturer. I mean, it's like, if you want to make a comparison, and if you want to talk to your students about this, it's like when you're in that level deep, which again, most technicians are not going to get that far deep in the water, but when you're that level far deep in, it's like you're walking around carrying half a gallon of fuel in your hands, and every false move you could make has got a spark next to you. It's a lot of energy dense in one spot. And again, it depends on the manufacturer. Some manufacturers, and especially in the heavy duty side, they're going to be serviceable. I mean, you look at the Ford and the GM, some Ford and GM models, it's like you break it down to a few different packs. You see guys repurposing them all the time for homemade power walls. And I know, Dave, you've rebuilt numerous batteries, swapped out a bad module for another recycled module. That level, for certain manufacturers, there are probably students of yours and technicians that that are already getting to that. Not necessarily at the dealer level, but at the independent shop. For certain cars, where you can break the battery down into a few bigger chunks, find which one is wrong, grab a used one from the recycling yard, put it in, and get it to work, that level is probably going to happen more and more.
Yeah, it's cost. It comes down to cost and time. Like I just had somebody call me about a Nissan Leaf 2014, beautiful shape, 24 kilowatt hour battery. It's down to like 60 kilometers on range. It's down, I think, to 8 bars. It's out of warranty. And I'm looking at like a used replaced battery for it. Whether we rebuild it or we swap it out, the cost is still, $5,000+. I hate throwing numbers out there. And, then they have to evaluate, is it worth doing? But don't get me wrong, gasoline powered vehicles are no different. I had an A5 Audi with a blown engine, and it was $6,000 for that engine. So, so the cost comparison can be very similar depending on how you're purchasing them and how you're buying them. So, but so that's where we're going to see, is that, can they be done? Sure, they can be done. How much do you want to spend? Well, that becomes the end game right there. So
absolutely.
Well, we don't have any more questions, so I want to thank Dave for his time and Nathan for his time. We will be doing this again. Nathan, do we have our date picked for the next one? It's going to be...
Do give me a moment to ensure that I give you the right date. It's in December, of course.
Yes, it's in December. Like the week after
December 6th. Yeah. Same time, same place, Wednesday, December 6th.
And we're going to be talking about PPE and safety, correct?
Yeah, and the components on the vehicle that are related to safety, protecting both the technician, drivers, on an electric vehicle. So
just one last reminder: everything on this webinar will be up on our YouTube page, probably by the end of the business day. I also share the link on our Facebook page if you follow that as well. Again, be sure to subscribe to our YouTube page, because we're going to put up very soon. We'll be putting up a video of how to use the Ohm's law as it relates to EVs. Some great circuits we're going to be building.
Yeah, totally.
All right.
So I want to thank everybody.
Yep. All right.
Sounds great. Well, thank you everyone very much and have a great day.